thank you all for having me here. Today I want to talk about making hybrid apps, and by hybrid I mean mobile hybrid apps that don't suck. And it's challenging, but it's not actually as bad as you might think. A little about, my name is David Muto. You can find me on the internet in all the places by Muto, which is my handle. And I work at Shopify. For those of you that don't know what Shopify is, we're a commerce platform that tries to make commerce better for everyone. Currently, we power over 200,000 stores worldwide, and things are going good. Yeah. For the last little while, I've spent time trying to figure out, can everyone hear me okay? Yeah? Okay. Trying to figure out a nice, practical way to develop a hybrid application. Specifically, we wanted to develop an app we called Cello. And the idea is that it's the easiest way to sell anything to anyone, anywhere at all. Easy goal. Like we set out simple. We just wanted to start with the easy stuff. We tried literally every framework you can imagine to come out with hybrid apps and found none of them are really up to the task yet. I don't want to name any because I don't want to be that guy that hates on projects, but lots of them have really good intentions and really good ideas, but you just don't get a native feel when you use them, and that made them a no-starter for us. So we went through and did a lot of thought in like figuring out the right trade-offs, like where you can get away with using web technology and where you have to really get down to the metal on the native side. And I hope today to share some of the big ideas with you anyway. I'm certainly not going to go through a code base line by line. There is a lot of code in these slides. I did my best to make them as big as possible. I'll make sure these slides are available. Also keep in mind, none of the things require you to go from top to bottom and read all of the code on the screen. So I'll do my best just to highlight the parts that are important. The next step, I didn't want to test the demo gods because they're forever against us when you're standing up here. So I made a video that shows what our app does so that I didn't have to go, fuck, no, that's not what it's supposed to do, try again. So it's a relatively short video, but here's just like one of the major flows, which is creating a product to sell. So you click the plus button, you get a camera, take a picture, scale it, size it, crop it, enter in some text, this stuff you'd expect to see. We manage inventory for you too, if you like. Little description, because we want to be good citizens. You have a product. You can preview in your store. Then we're going to go and share it to Twitter. You get a custom URL. You can see that it shares to Twitter. Then you can click on it, check out your mobile-friendly storefront, which is good. Looks pretty good on desktop too. The next step would be that someone actually buys your product. You'll get a push notification telling you, oh, someone bought your product. Brings you into the orders. You click the order, you can see that it came from Twitter. And then you can actually see on the map exactly where they came from. In our case, we used our address in Ottawa, but it would work anywhere. Some of this stuff was native, some of this stuff was not. And a lot of times it's not the stuff you expect. I'll leave it as a mystery, because it's kind of better that way. So we had some initial ideas we wanted. When we started to build this out, we had this strong aversion to local state. What I mean by that is we didn't want a database anywhere. We didn't want like local cached files. We didn't want this like offline syncing mode, which we deal with. We have native apps for our Shopify storefronts that deal with this. It's really complicated, so we wanted no complexity. So that was the first idea here. The web is the one and only source of truth. There is no other data anywhere else that we have to like figure out how to make valid. The next step was like figuring out, okay, we wanted navigation through the app to be driven by the web, but actually executed natively. Because if anyone's ever seen web browsers on native devices, they suck horribly at this. But native apps are really good at navigation. So we wanted web for most things, but native when it counts. And only when it counts, only when it actually makes a difference, when it gets hard. And lastly, native code bases mean native code releases, which means you're dealing with app stores or play stores. We wanted to keep the native code bases as small as possible and share as much as they possibly could. So, with these three goals in mind, I'm going to go through a whole bunch of stuff. These are just major like building blocks and stuff we ran into. Yeah, this is my segue. That's it. So there are really, for those, everyone's probably familiar with these. There are three types of apps you can do when you're doing mobile. Certainly there's variations of all of these. There are mobile apps that are written entirely in the native language from the native platforms, and then they just communicate with an API if you need to do something. There are web apps, in my opinion, these are the worst ones. Web apps are simply, you get a native shell of an application that just opens a web view and then everything happens inside that web view. Even navigation, everything, all inside the one. And then there's like something in the middle, which is what I want to talk about, and that's hybrid. In my experience so far, this is a good approach as long as you can figure out the right trade-offs. Some of the things we were looking for are like rapid iteration of content, and you get that from the web app model, and we wanted to bring that part over. If I need to change something, it's not a native code release. You just test it out, make sure it's good, push to prod, everyone has it. That part I liked. So updates without the Play stores. And then we wanted to be able to leverage existing technology in teams. So it's not just like me and 3 other people that are working on this. There's 300 developers across the company. So we want to make sure that I don't need them to learn absolutely everything from the bottom up to get started in this. I wanted to use some technology we already have and some people that we already had, which is great. So a couple of little doing it rights before I get into some code. Some people, and they are almost always native mobile developers, hate hybrid apps. You don't even have to tell them what your plan is. If you just say hybrid app, they're like, oh, never mind. Like, that's the nice way. Or they'll start yelling at you like you have no idea what you're talking about. And it's usually related to all of their bad experiences with the existing frameworks that are out there today. There are some good ones, some bad ones. Some of them are still like working out their kinks, but so hybrid apps don't have to suck. And I'm going to show you today some of the building blocks that make it so they don't suck. And you'll probably come up with some other ones, hopefully. Another myth that we have here is that people think you have to be an expert in every mobile tech in order to get started, and you really don't. That's not necessary. I will say that you do need some experience or a willingness to learn. Particularly, the language isn't really the problem for anyone that's tried to learn Objective-C, Swift, or Java, or any other language. The language is the easy part. That's a couple of weeks, tops. If you actually work in it all the time, you just get used to it, and you pick it up naturally. The hard parts I found for bringing people in with no experience on mobile was getting used to Cocoa. Like, do you know how Apple's whole infrastructure works? Do you understand activities and fragments and their weird life cycles in Android? This stuff was the hard part, not Java or Objective-C. This was the difficult part. So, the very first steps here. We need some way to have a JavaScript object on a page that we can use to send a message to the native app. So the idea is you click a link, and something should tell the native device to do something. There are these are network messages. So this isn't these aren't network messages. So it's not a web request we're looking for here. It just feels like one. It happens from inside a browser that's already on the device, and we want to send the device a message. There are some things in place if you're using, like iOS's framework has JavaScript core. If anyone's heard, I don't know, there's this thing maybe you've heard of called React Native. They use JavaScript core. There's no equivalent on Android, and we didn't want to have 2 different client-side libraries to work with. So we ended up just making our own, which I'll show you is really not extremely challenging, at least in the pared down examples I'm going to show. So here's the first step, and the first part of lots of code. Again, don't try and read all of this, especially from further back. It's okay, not all of this is necessary. The point that's important are a web view gets configured with a script message handler. This is something that will respond to events from the website. And the actual body part is whatever you delegate as that script message handler will receive a message. It's going to have a body. We pull that out, we get an event name, and we now have some generic way of dealing with events that come with a JSON object as options. Similarly on Android, again, don't worry about all the configuration stuff. I will be posting the slides, so you're welcome to go through it, but a lot of these have been pared down. I pulled out error handling and all sorts of stuff that you should actually do, but it might be enough to give you an idea. The main point here is to add a JavaScript interface. We're going to give it a name. You see it's called native app. And then this is what happens when you execute an event. And that can be pretty much anything you like. Calling it from, all of my examples are in CoffeeScript. I'm a fan. Don't hate me. ES6 is pretty good too, but yeah, I like coffee. So calling it from CoffeeScript is as simple as, since we expose this as a native app and use the built-in system on each framework, it will expose a native object called native app That, again, is not a web request. That's going to be there even before your scripts run. That gets injected, then it loads the URLs. So it's going to be available. So at any point, you can call native exec, pass an event. It'll strip out the event name and options and send that along. So far, so good? All right. So now we have a way to send events from the web to native. Now we got to set up a few things on the Rails side. I'm assuming Rails. Yeah, I'm a fan, so I'm assuming Rails. It's much easier if you're building a brand new app, but let's face it, well, okay, I shouldn't say let's face it. My case, I wasn't building a brand new app. I have a bunch of stuff already in place. There's already a Rails app we have for Shopify. We wanted to leverage it as much as we could without littering our code base with if cellos. So like the app that I made was called Cello. If cello, do this, otherwise do the normal thing we wanted to avoid. But in every other case, we're trying to reuse as much as we can. We also want to be able to support multiple versions of the app in production because like it's not websites. So once you push an app in prod, especially on like, for some reason, iOS people don't like to update all the time unless you ping them. Android, luckily now, it's kind of like a default option where it just updates in the background unless you tell it not to. So once it goes out there, we're going to need to be able to continue to support those apps, even if we make changes to the flow in the website. That part's always hard. So we start by, you need a way to identify requests that are for your app or not. In our case, we had an existing application, so we made a concern. You should be concerned when you see this kind of code. Not yet, but on the extension of this code that's coming up, you'll see what I mean. So all we're doing really here is we're mapping the user agent that comes in with the request, which we set on the native side, to some pattern we have. Our pattern changes sometimes, but usually not often once it goes in. You want to just be sure to include the name of the app, the version, and like the specific platform in the header. That way you can make decisions on those things. And those are native changes, so you want those in as early as possible so that you don't have to ship a new version of the app just because you changed this. So I'd put those in as early as you can. The next step is to set the request variant. So for anyone who's not familiar with Rails variants, it's like a specialization of the request format. So if you're used to seeing code that says respond to, do, format, and then you have format HTML, format JSON, those now can take blocks as well, and inside of those you can test for a specific variant and render a different view. So you end up with the same controllers. You can automate this just by naming your view. Like in the case of index HTML ERB or something, you would do index HTML plus your variant.erb, and it will render that instead. Could have used a custom view path, but that seemed less Railsy, so I didn't. This is the scary part about concerns for me. Once you start adding filters and concerns, it gets really hard to trace when something happens because it's not, you can look through the controller all you want. You're not going to see that before filter. So if you make this decision, just be sure to like do it on purpose and you know that this is a thing and that means that other developers that are debugging code are going to have trouble with this at some point. So what we did here is if it's a Cello request, then we run the before action that sets the request variant to Cello. So far, so good. Coming along. There's going to be a lot more code. At some point, everyone will be like, the next step is setting the app version. So we want to know what the version of the app is. In our case, our user agent pattern has two groups, and we know we can split it up this way. So like the first group that it matches is the platform. For us, that's either iOS or Android. You can certainly add as many as you wanted and any variations of them. And then we use a gem version because it does all the goodness you want for like matching versions. In this particular, like an example of doing this, you'd want to know if you were going to show a camera, you'd want to know that the device, like the version of the app that's running on the device is a version that you put out that supports the camera before you put a link on your web page that goes out to everyone that opens the camera that some apps might not know how to handle. Then you're going to end up with a bunch of crash logs, and that's no good. So you might want to use the version. Finally, you want to be able to sunset old versions. And what I mean by this is like, if someone installed the beta version and you're on like version 8, at some point you're going to want to stop putting all these if statements all over the place to check the version or coming up with some other construct to do it. So we wanted a way to be able to like take old versions out of prod. And what'll happen is someone will open the app, it'll detect, hey, wait a minute, like this is the wrong version, and it sends an update required header and kills it. I would be careful. We chose to use the upgrade required header. You should know that's HTTP 426. Some networking libraries actually use that for what it's meant for, and the RFC says it's meant to tell you the version of HTTP is too old, upgrade required. I don't know of anyone sending old HTTP 1.0 requests, but if you are, make sure the libraries you use don't have this problem. Ours don't use it, so we were free to use it. Some other things to consider, restricting access to actions. So you might want to say, oh, this action's only available if it's, in this case, an app request or a web request. I would suggest using a whitelist instead of a blacklist. It's up to you, but being explicit is usually clearer, especially as your team size grows, it's easier to see. Clever isn't always good. There is, of course, our good friend Action Mailer. Everyone loves Action Mailer. There is no variant support in Action Mailer. That's right. Let me say that again. There is no variant support in Action Mailer. So if you want to send different mail based, like mail templates based on your request, and you go, oh, well, I'm setting the request variant, it'll all be good. It's not. You'll have to monkey patch it. That's what we did. If you can find a way to make the Rails core team happy, you can put a PR in Rails core, an upstream PR, but it would have to be pretty, like, it's really difficult to do since a lot of people use Action Mailer for different things. It'll be hard to get that PR through, but I'm really hoping someone here tries. Yeah, please try. All right. The last thing is you might want to handle custom domains for your requests. In our case, we do. I didn't have any code related to that because I think I have enough code in this slide, so I think we're good. But that would be easy enough to do, knowing that it's a seller request. You could verify a domain as well. So far we can identify app requests. We can show specific views using the variants. And we can send events from Rails to the native side. And now we need to be able to send events the other way. I need the native app to be able to tell the web view to do something. So this is where, like, the big idea, this is like, of all the things we're going to show, or I'm going to show after this, they all really depend on this idea. And we called it the Event Hub. Any other name would work equally well. But the idea is it's a bridge between the native device and the web view. So it sits right in between the two of them. It operates on this asynchronous pub-sub model, so like you publish an event and anything on the other side listens, hears it, and handles it. They might publish other events. So it allows native code to trigger web behavior and vice versa. I drew boxes. I was pretty proud of myself for this. This is actually a vector diagram. I could scale this anyway. No. So the way it works is it sits here, a controller or a fragment, depending on your platform, owns a web view, an event hub is attached to it. You register receivers for different type events. Perhaps handler might have been a better name for different types of events. And then there's the global notification system. So an event comes in, the event hub goes, hey, wait a minute, I got an event. Let me notify all my receivers that are supposed to receive this event. And then those receivers do something. Usually they delegate an action out to either a delegate or a callback. Most of the time, I would suggest using the thing that owns the web view to be that delegate. That just makes it easier to follow. I'll show some terrible examples. Again, lots of code. Don't worry about reading all this code. The idea is that execute comes in. There's an intent on whether or not it should be a global event. If it's global, we make a global event. If it's a local intent, then we make a local version of it. So it just loops through all the event receivers and says, oh, if you have this action, do this thing. An example of a receiver looks like this. Handle event actually just pulls out the URL attribute from the parameters and tells its delegate, push a new URL. Whatever that means. I'm going to go through navigation after this section, but it might mean pushing a fragment onto the backstack. It might be pushing a navigation controller onto the UI navigation controller. Yeah. Similarly, in iOS, I think this is the last example where I do it in both. From this point on, I'll pick Android or iOS to go through as an example. Similar code in Objective-C, very verbose. If it's broadcast and it has the broadcast prefix, then we're going to go through and broadcast a global event. In the case of iOS, that's actually through the notification center. Really strive hard not to use this for navigation. It's really, really hard to follow if you do. So I strongly suggest using these local events whenever possible. Then you have local receivers. Again, similarly, loops through each one. Should I handle this event? If I should, do something. If I shouldn't, just keep going. A receiver in iOS looks very similar. We have an added extra thing that I really don't know why we did. I don't think there's ever a case where we animate without animation. The whole reason we're telling the OS to do it is because they do this nice animation and transition. We would never send no for that parameter. It's always yes. But anyway, so we would tell the receiver to handle the push event. And then again, the last step here is the website to make CoffeeScript work the exact same way. Again, lots of code we don't need to do is go through all of it, but the idea is you can execute an event. That'll create an event object and dispatch, and anything that's listening to it will get that event. We have sorry, I gotta figure out this microphone distance. We just subscribe to the native exec event, so we can call from at any point in CoffeeScript, event execute native event. You give it a name and a JSON object, and it sends that over to the event view on the native side. All right, still so far so good, I think. In this particular case, there's a few suggestions I could make. I would start by making a base class. There's a lot of plumbing code that goes into setting all these things up. If you can deal with the inheritance, I would suggest doing it. If you're leveraging an existing app, maybe you can't. You can find some other way. Receivers can be added to subclasses, but generally speaking, most of them are common. So I'm going to go through a few different types of receivers that we made, but you'll want to be able to handle page pushes, page pops, error happened, all sorts of things, and they're pretty much always the same unless you have something very specific, like the camera example I showed earlier. And then, I already mentioned this, but I would definitely use the controller or fragment or the thing that owns the web view as the delegate for the receivers so that it's really easy to follow what happens. Typically, you're going to do something that involves a native, like a UI context anyway. So if you tried to delegate it out to another object, you're just going to get another level of indirection that eventually will have to tell the controller or the fragment to do something. The last little bit about the event hub or global events. So there's global and local. Local events are sent to individual event hubs, and they're attached to one web view. So they're telling the currently on-screen web page to do something natively. Global events are sent to the notification system. So on Android, you'll broadcast a local intent. On iOS, you'll push to the NS notification center. I would think of these as like logout. So imagine like the logout event. It doesn't matter what page you're on or where you are in the app. Logout means like clean up all the things, delete all the data, send a request to log you out, make sure nothing's there, and go back to the login screen. I don't care where you are in the hierarchy. I'm not concerned about anything that might be listening to other events. Just clean all this stuff up. Cross-page refreshes are another example. So I showed a product listing. You edit a product. I want this page to upload or update as well as the other one. For that, you would need a global event. So we can identify app requests. We can send events back and forth between native and web. And now we can actually start using that to do something. So the first example I'm going to show is navigate. Oh, I lied. The first example I'm going to show is loading pages. I switched those. We don't want to get really chatty with the web APIs in general. So what will happen for the most part is we want to send down one event that comes and gives you all the info you need in order to render. That means setting up, if there's an action bar or a UI navigation bar, like you'll want to set those up as part of the information that comes back when the page is loaded, not as a separate request that happens all the time to figure out what to do. So as an example, what I mean here is like this title and this button are displayed natively on their respective platforms, but they're defined in the web view that gets returned by this view. There's a picture here and other stuff. So the event hub's already in place, so we can use that to our advantage. The idea here would be to send a page loaded event that happens like as soon as the page loads. It doesn't even wait for DOM ready. Like as soon as the page is in, we call some code that strips out some meta tags in our case. I'm going to show the example here. So you might have some code that looks something like this, where we set a title, then we have a little helper here, bar button, that just sets a bar button item. To save you some more code and not having to read the helper, here's the rendered result of what you get out of it. You get a title tag, and then a meta tag that I, for clarity, broke apart, so it's easier to read. But the idea is we called it app navigation. It has an action that it's going to run, a label, and some options it's going to send through. Firing the event. So from CoffeeScript, we're going to execute a native event called page loaded. It needs to take an option, so do is just going to execute this method and return details. we send the document's title and we strip out all of the navigation stuff straight out of the meta tags and send that event over to the native device before we've even finished loading this page. Basically, as soon as possible. Once the head section's rendered, you're good to do this. As long as you don't depend on anything that requires the DOM to be ready. And then handling the event is as easy as like, you get back the options, we process the title, process global event. I didn't want to give pages and pages of code to how to do these things, but you can imagine you get a JSON object back, a dictionary, that has all of the properties you set, the title, anything you wanted to build from it. And then the last little bit is did finish loading. So we had a few cases where we were doing some animation, and since page loaded happens, then it finishes rendering, the animation would start before the rendering was done, and you would just catch the very end of it. So we made an event called did finish loading that we call, essentially a web page comes in, tells the native device that it's loaded. The native device does what it needs to and tells the web thing that it's finished loading. And then you can start things running after that point. That's loading pages. Sometimes you might want to present modals. I would strongly suggest against modals whenever you can. But if you do need to use them, they're pretty easy. We first want to trigger an event, so I have a little CoffeeScript object here that creates a modal with a title. I made these fancy add submit buttons and add button. They're really just like adding other JSON parameters to be sent over to the native side. On the native side, we have a receiver. It handles the event. It grabs the params, which are really like button with its definition, just JSON objects, really simple things that you can read from. And then, yeah, I didn't want to, again, show all of that code that parses JSON, but you can imagine what it does. It parses JSON and then adds buttons. The next step, so now we can identify requests, communicate back and forth between web and native. We can display titles, bar button items. If we wanted to, we can show modals. The next step is navigation. And after you get navigation, you pretty much have like a functional app. You can do some stuff. Mobile browsers, as I said before, truly suck at navigation. They just do. You click a link, like, did that work? What's going on? Oh, there it is. Oh, no, there's half of it. Oh, there it is. And then you click another link. And even like, that's the one that ships with the vendor, so it's supposed to be the best implementation, and they're still not good at it. Every native platform has their own way of handling this like navigation stack, so if you're working with iOS, you're usually using a UI navigation controller or some class you made that is really just that. On Android, there's backstacks for fragments, or you could end up just like pushing activities, so like starting new activities, which will keep the backstack in order on the system. We chose to do that for some memory considerations. Fragments like to retain themselves. We can actually use the device to do this. We have the tech, but it's already there. Again, so if we wanted to handle push events, very similar to the other ones. I'm going to show, I think there's 3 slides here. They're all almost identical. It's all in just how they deal with it. You're going to get a JSON object that comes back with a URL property. You read that URL property in, send it up to your delegate, and push a view controller. That way the device handles pushing in it. So it looks like just every one of your normal iOS apps. You click something, a new controller pushes on top. You get the animation, it looks good. As opposed to like, click what? Is that working? Is that working? Pop events are similar, so if I wanted to click a button that will remove this off the navigation stack, again, I want to let the native device do that, so you just push it through. Again, very similar code here. Grab some details, check should I pop to root. This allowed us to be able to like, from 2 or 3 levels deep, pop all the way back to the root in the navigation controller. It's a little trickier in Android, but doable. Page load events, very similar. Again, if we wanted to handle a page load event, we're going to get the URL property out of the params. Load just tells the current web view to load a different page rather than pushing a new view controller. Not used as often. Keep in mind that these examples, if you're looking at them, have been cleaned up for clarity. There's like certainly things you should be doing. Handle errors. Someone is going to send you a bad URL. Don't try and render it and fail. You know up front that it's a bad URL. Like figure out a nicer way of handling that. Triggering navigation is just using normal link to helpers. So we have a class that we added, link native. There are 3 things you can do with these. You can execute a native event, so some known event that you've made on the other side to be handled. And that's just by adding a data attribute. You can push a new activity onto the stack. This is the most common by far. This is the standard link click would really do this, push an activity on. So the native activities don't work like websites where you click through and you browse around and every screen is their whole experience. It's usually you're on a list and you like a master page and you look at detail and then you might look into more detail and then you're going to come back rather than just navigating through everywhere and losing your previous state. If you wanted to just run a load event, it works like this. Very similar, and then you just have to write a little piece of code to trap those clicks. Again, instead of trapping all clicks, I'm a fan of opt-in. Like, don't trap all clicks. If the class is link native, then we're going to handle this event. And all we do is really stop the default event from happening, find the link. If it's an event, execute native event. If it's specifically a page load event, pass the href over. All of them in every case are calling a native event to do something. It's telling the device, do this now, do this now. So with this, you can do quite a bit. Like you could get a basic, if you had a website that you wanted to make a mobile experience for, this would be enough, usually. So we can identify requests, communicate back and forth, display titles, bar button items. We can delegate navigation to the device. This is all good. But every once in a while, someone wants to change something. That's when it gets ruined. Someone will want to actually like submit a form. And like, no, this is brochureware. You're not supposed to do this, but no. So we have to find a way to handle forms. And specifically, like everyone will always talk about round trips are expensive and you shouldn't do these kind of things. On mobile devices, like add a multiplier to that. It's a big deal, not only for their bandwidth, but like internet connections come and go quite often. And then it's expensive. The timeouts are really long on mobile devices. So like they click a button and it takes 30 seconds to tell them there's no network available. So like if there's anything you can do up front, you should, anything at all. Especially like validation, which is generally a good practice anyway, but it's extra important in this particular case. For validation, you'll want to show them that this field is wrong. I suggest putting a banner or something on top because you can't control screen sizes. Sometimes the field that's not valid is not in view. And if you don't put that banner there, they're like, I don't understand what's wrong. And they just keep mashing the submit button over and over and over again until you love it. I'm going to breeze through some of this code here. Make something that can validate, as an example. It just has methods. Not all of those are great. Then we made this form handler that takes a form and attaches a set of rules to that form. Mostly, we usually parse the form for it. But it goes through and validates it. If it's valid, it checks all the fields, make sure it's good. So the trick here was just to set the data form handler, and then you just get these validation rules. Now, you can do this any way you like. This example here isn't particularly interesting. Everyone has a way of solving validation. The most important thing is that you actually do it. So don't just validate that it's required, but that it's actually an email address and that it's formatted the same way your server expects to find an email address so that you can avoid these like costly back and forths. Handling form submissions. We made a form handler. It's simple. It just has some basic JSON things that we have to set up. The important part is should submit can actually ask the form handler itself if things are valid. And then we did this like little start submit, finish submit dance where we wanted to have start submit means that if it's valid and it's good to go, then finish submit, which actually goes through and makes the promise and does the work. But that also gives you the ability to subclass this form handler. So in some cases, you might want to show a Muto before you submit. This is how you could do it. Just inside of start submit, show the Muto, and depending on the result, then call finish submit. Again, lots of ways to handle it. It's just important that you do handle it, however you decide to do that. So again, don't forget to show banners when validation fails. Again, it's really common that on like somebody still has an iPhone. Does anyone have an iPhone 4? Yes, there's always one. I work with the one other person in the world that has an iPhone 4, so I know all the other times when they click submit, they can't see the field that's actually invalid, and they're like, I don't get why it's broken. It's not broken, you're broken. But anyway, mobile devices can be really, really slow sometimes. Again, especially during these like transition from network available to not. There's a long time out to give them a little bit of a window. You should block the UI during submissions, and by that I don't just mean like throw up a big screen and be like waiting. Do a little animation. Give them some, like this is going to be natively implemented anyway. Like make something exciting that they can see, not a spinner. Okay, everyone hates seeing spinners. Nothing will make your application seem more like a web app than a spinner. I'm not giving you the time cards, you can't even see. And finally, don't do anything natively to control the flow. So if like the form submit happens and it works and it's successful, let the response delegate what to do. Should I push a URL? Should I pop? These are things that allow you to change the app once it's in production. You can change the behavior by changing your web library as opposed to changing the native apps. If you make a special case here, you can never change it unless you go through the App Store, wait for them to submit it, then they decline it because it doesn't work on iPads, but I'm not supporting iPads, then you wait another week. It's a very long period of time to be able to make a change here. So you want to make sure you, like, no exceptions to this rule. And then, yeah, the worst, errors. They're just gonna happen. There's nothing you can do about this. They will happen, and they're gonna happen at the worst time when you, like, the errors that you expect to happen don't happen because you planned for them. So it's all the other ones that you have to be worried about. There are a few kinds, but specifically app crashes. You like that first point? These are important, just in case you didn't think a crash was important. It is important to track what happens here. There are third-party services available. Hockey and TestFlight are the two that come to mind. And they'll send you crash logs. So halfway through your app, something went wrong, it crashed. The person goes to open up the app again. Hockey goes, oh, there's a crash log, and sends it up. The only thing to note here is that it's only sent if they open your app again. So if you crash like a few times, and then like that's it, I'm not using you anymore, you're not gonna find out about the last one and what happened. The other thing here is to actually look at these. So I know lots of teams do this part, where they get crash logs because they feel like that's the responsible thing to do. And then when crashes happen, nobody actually looks at the logs. They're just like, oh, that's only affected 2 people. Then next week it's 8 people. And then it keeps going up, and usually inevitably somewhere down the line, you go through, and it's been the same problem the whole time, but nobody looked through it. So I would strongly suggest to do it. This is one type of error. The worst type of error, yes, the worst. I think Stockholm Syndrome has pretty much made everyone work with JavaScript. So this is a thing. They occur inside the web view, which means they're a little bit trickier to track because you're really showing a native window that has a web view in it. When an error occurs, nothing will happen on the native side to let them know. They can make your app seem completely unresponsive. So if you like click a link and nothing happens, it's not like you see a console log when you're using an app. It's just like, oh, nothing happened. Click again, click again. You want to know about these errors. And like sometimes people will tell you, if you get really good users that will file bug reports, that's amazing, or at least complain. Please complain on Twitter. At least I'll know about it. This is a good thing. But lots of people just go, oh, it doesn't work, and stop. So you want to know that these things happen. We can include errors in our logs fairly easily, though. Again, using that same idea of the Event Hub, we're going to do something terrible and hijack console log. So yeah, this just happened. I just did that. And then make a new function called logger that applies the original console log, but also sends a native log event to the device. So anytime console log gets called from a JavaScript context, it's going to do the normal thing and this other thing, which is to send a log event down to the device. And then here's where we hijack console log. Yeah. I strongly suggest monkey patching all of JavaScript if you ever have a chance. No, don't do that. Please don't quote me on that. The other thing is when an error occurs. So a JavaScript error isn't necessarily going to console log unless you told it to. But the window on error event will happen when JS errors happen. So we just added an event handler to this that actually sends that error down to the native device so that we can include console logs and error logs in the crash logs. So we know about their whole session, not just their native session, but the web session as well. Then you got to handle those errors. That's easy enough. Same idea with an event hub. Handle event. It'll go through the event hub, handle the receiver. And the last type of error, network errors. Very well-designed networks all around the world for telecommunications. It's super common on a mobile device to have network, not have network. Oh, I have network again. Oh, not as good. Let me go back. Gone, back, gone. This is a really common thing, and you just have to try and work with it as much as you can. You can mitigate some of this with proper timeouts. So like, you don't have to wait forever. If an internet connection's not available and you're ultimately gonna fail and do something, I didn't see the card. No, I'm kidding. If you're ultimately gonna fail, then you should fail earlier. If you know what you're gonna do, like fail is whatever a reasonable amount of time seems to you, maybe 5 seconds. If it doesn't respond in 5 seconds, maybe it would in 15, but will the user still be there? Maybe not. So like, don't wait for the long timeouts that come with it. So fail fast and gracefully. One way you can do this is like, when there's no connection on the native device, you can register to receive changes to the network status and show a page that just says there's no network available. In our particular case, because of that no local state rule we had where the web is the only source of truth, it's essentially unusable without an internet connection. So I'm not even gonna let you try, because then you'll just get frustrated. Show something that says network's not available. As soon as the network comes on, hide it, and you're still back in the same part where you were. So we can identify network requests. We can communicate back and forth between web and native. We can display titles, bar buttons, present modals. We can navigate. We can deal with errors. We can handle form submissions. Somewhere in here, we even dealt with JavaScript somehow. I hope this convinces you that like with a little bit of code that I showed here today, it took about 40 minutes to go through. Certainly this is not a complete example, but you don't need to rely on a framework that's not really gonna work. You don't have to be afraid of writing your own thing. By all means, leverage what you can from someone else. But yeah, with that, I think I'm done. My name is David Muto in real life, pseudo Muto on the internet. If you have any questions, feel free to follow me or ask now.